Okay, welcome back. So this is video 4. This is the last video for ellipses. We've been doing a whole lot where I give you some information, like a graph, and you write an equation. I give you bits and pieces, and you write an equation. It's a little bit more difficult when we're not given both the vertices and covertices. So what happens if we're given either or, a vertice or a covertice, and a foci? So that's what these problems are all about. Let's do 5A together. I'm going to do 2 practice problems with you, and then you're going to try 2 on your own. Okay, so 5A. Alright, so if they gave me the vertices, that means they gave me some information off of the major axes, the longer axes of symmetry. So if I look at these 2 points, the x values don't change, the y values do, so it tells me it's going to have a vertical change. So if the vertices, or the longer axes, have a vertical difference, this is going to be a vertical ellipse. It's going to be tall and skinny. Okay. Let's find the center of the ellipse. Since I was only given the vertices, I have to use those. So we're going to use the midpoint formula. The x1 plus x2 and the y1 plus y2. Both of those being cut in half. So I'm just going to plug in the coordinates. x1 and x2, we've got -9 and -9. And then we've got -2 plus -12. So let's simplify that up. That becomes -18 over 2 and -14 over 2. And we'll get -18 divided by 2 is -9. -14 divided by 2 is -7. So right here is my center. So let's find some more information that we're allowed to. The vertices are on the major axes, so it's going to help us find our A value. So let's find A is going to be our major axes cut in half. So to do that, we'll do the distance of the change. So we're going to do -2 take away -12. Cut that in half, so we get 10 over 2, which is 5. So if A equals 5, then A squared is going to be 25. Now I don't know where that 25 goes yet, but it's good to have. I cannot find my B. Why can't I find my B value? That's because we weren't given the covertices. We were given the foci though, so we're going to use that to our advantage. Let's figure out what C is. So for finding C, it's the distance between foci cut in half. So we're going to find the distance between them. There's a change in the y's, so we've got -3 take away -11, cutting that in half. So -3 plus 11 would be 8 over 2 equals 4. So C is equal to 4, or C squared is 16. Now, this does not go into our equation of the ellipse, but you'll notice that we haven't found b yet. We need to find b. So let's figure out what b is. We know this lovely equation, c squared minus, or is equal to b squared. Ugh, Thomas, you're moving too fast. C squared is equal to a squared take away b squared. So we have a c and we have an a, but we don't have b. Let's solve for b. So we've got 16 is equal to 25 minus b squared. Let's solve for b. If I were to move b squared over here and 16 over there, you'd have 25 plus, oh, nope, take away 16. B squared equals 9, so that, well, you could do this. You could say that b is equal to 3, but we don't really need that. We just need what b squared is. Okay. We have all the information we need. We know it's a vertical ellipse, so the larger denominator is going to go underneath the y value. So the larger denominator is at 25. So we're going to have x take away h, which is negative 9 from up there. That's going to be plus 9 over, the smaller denominator goes here, so it'll be 9 plus y minus negative 7, or plus 7 squared over 25 equals 1. And you are done. Okay, so that was an example if we're giving vertices and foci, and we didn't have the co-vertices. So we're going to do an example now when we're not given the vertices, but we are given the co-vertices. So here's 5b. So this one's different because before we were given vertices, now we're given co-vertices. Alright, so let's talk about the co-vertices. That's going to be on our minor axes. So this one has a vertical change of, what is that? Well, it doesn't really matter, but the change is vertical. So if the co-vertices is vertical, that means the vertices is horizontal. So this is going to be a horizontal ellipse. Let's find our center. To find the center, we do the midpoint formula of the co-vertices. So we're going to have 2 plus 2 over 2, 7 plus negative 9 over 2, 4 over 2, negative 2 over 2, and our center would be 2 comma negative 1. Okay. If you're not sure how I did that, or if I did it too fast, rewatch the video or go back to a couple videos to see what I've been doing to find center in the past. Now we should find our B. Why are we finding our B instead of our A? Well, we can only find A if we were given our vertices. We were given co-vertices. Those are the smaller ones. So B is minor axes cut in half. So let's find the length of the full minor axes. That one is going to be, this is between 7 and negative 9. Cut in half. So we've got 16 over 2. 8. So if B equals 8, then B squared is 64. Okay, so we have our center, we have our B. We can't find the A, but we can find the C value. So C value is the distance between foci cut in half. So foci distance cut in half. So the change is between -4 and positive 8, sorry. -4 minus 8 over 2. We get -12 over 2. But remember, since it's a distance, we don't really need that negative. So this is just 6. C is equal to 6, so C squared equals 36. Out of these two pieces of information, we only really need this one, but we're going to use the C squared to find the other piece, the A squared. So we've got C squared equals A squared minus B squared. 36 is equal to 64 minus B squared. So I could, if I wanted to, add B squared over here. Hold on. I messed up. Do you guys see how I put the 64 in for A? Don't want to do that. We're trying to find A squared. We know what B squared is. That one's 64. My bad. So let's add 64 on both sides instead. So if A squared is equal to 100, I'm done. We're good. We can start using that now. Alright, here comes the formula. X take away H. Our H is 2. And then we're going to add that to Y take away K, which was -1, so it's going to be +1, over something equals 1. So we have this 100, and that's 64, but we don't know where to put it. Since it's a horizontal ellipse, the larger denominator is going to go to the X. So that means 100 is going here, and 64 is going there. Okay, so now it's your problem. So you guys are going to be doing, where are they? 5C and 5D. We'll write those out for you. So the directions are to write an equation of the ellipse. So this one is kind of like 5A. So if you need help, go back to 5A and look at that one. Okay. So there's 5D. C and 5D are for you guys to do. Alright, bye.